record to the cloud. So
Yes.
there it goes. Sorry, I'm
Okay.
late. Having
Go ahead,
technical
Dave.
issues.
Just not a great lot to report. I've been recording with the old program some logs, daily logs, which I haven't been looking at very much. And I have been writing some code in Python, at least for my own use, to make more, to do analysis on these files. That's moving along nicely, but nothing real exciting. That's it.
Fine business. And next on the list is Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks a lot, Dave. Sorry I was late. I'm trying to redo the cable management of my computer system over here. And that's a little scary because I have a lot of stuff connected in. But what I'm trying to do is I have the Kiwi SDR here. I have the Grape receiver that John Gibbons sent me. I have a brand new computer to do Ionosond chirp receiving. So I'm trying to get all of that integrated into my system here, so I'll be able to run all of those things. So that's my little between Christmas and New Year's project. So that's what I'm
Very
working on.
good.
Yeah. So W2NAF back to net.
Fine business. And next on the list is Bill, AB4EJ. Go ahead, Bill.
Okay, fine business. Sound check. Got me okay?
You're good.
Okay, thanks, Dave. Well, much like Nathaniel, I received a grape station from John Gibbons, and it's running, except that for me to actually put it on an antenna involves disconnecting an antenna from something else, and with all of the complicated stuff that I have, it's a little bit of a headache to continuously, because I'm trying to finish up this 5-band DXCC, and I'm using the same antenna for the grape. So anyway, what I've done is I've ordered an MFJ 1886 receiving loop, and I'm going to put the grape on that. So it'll have its own dedicated antenna, which they claim is good from like 300 kilohertz up to 30 megahertz. And so we should be able to get whatever different WWV station we want to copy on that. And this might be a recommended approach for a lot of hams who have antennas that they would like to use for different things without interfering with their regular station activities. They can copy WWV. Now, this is an antenna which is under $300, and so maybe it works out okay. So we're going to see. I have noticed, though, that with the grape running, that when I transmit, you can see a very distinct signal coming into the grape. The grape does not have the most sophisticated front end on it. It doesn't look like, and so the front end seems to maybe become overloaded when I'm transmitting on the same, well, in the same acreage as where the grape is trying to receive. So anyway, I'm going to have that probably up and running by next week, and then we'll see what kind of results we get from monitoring on the grape. So that's what's going on here. Back to net.
Fine business. And next on the list, we have Dan in for XWE. Go ahead, Dan.
Oh, thank you, Dave, and good evening, everyone. I've been working on scripts, believe it or not. Still chugging away with that. I have 11 of them on the GitHub site. There are 7 Raspberry Pi scripts and 4 Odroid N2 scripts. And it's everything from FLDigi to Pi, HPSDR to FreeDV, on the Pi at least. So it's kept me busy off the streets and all that stuff. So that's pretty much it. It's been very educational. And back to you, Dave.
Well, that should ease people's process of installing some of that software if they need that particular software. So next on the list, let's see, Bill, Dave, David McGaw, N1HAC. Go ahead.
Hello, everyone. Just directly related to this project, I've been reciting the new magnetometer. I put it into a plastic waterproof box and in the process of sighting it outdoors. I don't have it talking quite yet, but hope to get outdoor data and have it near a scientific grade magnetometer.
Good.
We'll see it's as I had previously mentioned, I recovered what used to be the Grafton, New Hampshire magnetometer and computer, and we'll see if it is still functional. Don't know how I'd get data out of it yet, but I know it will display on the screen. And then I have another magnetometer that will be available that is what we used to fly on our high altitude balloons to compare it to. So hopefully we have some comparison data coming.
Good.
And also working on a VLF project, not as sophisticated as what we'll be able to do with this, but looking to get data off of NAA and its propagation. So back to the net.
Fine business. So next on the list is Greg, VA3CBN. Go ahead, Greg.
There we go. Basically the same as last week. I'm just going to listen in. I'm a newbie and you guys all had to start somewhere. So I think I can learn a lot just by listening to you guys. Go ahead.
Okay. Well, fine business, and we're glad you're here. Next on the list is James, KG4DSG. Go ahead.
You got me?
Yep.
I'm here listening in, but I want to inform everybody that I am now the official owner of the missing red stapler from Office Space. It was a Christmas gift, so I now need to move to the basement. Back to net.
Very good. Okay. And next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I do not have much to report, but I did find something that I thought would be relevant to share. I don't know if any of you guys ever used JLC PCB to make your build your boards, but this was the first time that I tried them out, and I had a 5x7 board that was usually over $100 and at the other houses, and I only paid like $30 some shipped, and the quality is really, really good. A lot better than what I was expecting. Usually I get my boards made from OSH Park, but I got 5 boards for about $38. So I think when I'm finally ready to make some VLF prototype boards, I'm going to use JLC PCB. This way that they're cheap and they're really good quality. I was really surprised. Other than that, I do not have much to share. Back to the net.
Fine business. And I did hear a discussion with online with Lady Ada, and she recommended that as where she has development boards made. So there's 2 recommendations for that site. Next on the list, we have Jules, KE2KGJ. Go ahead, Jules.
Okay, well, survived. First of all, I hope everybody had a good Christmas. We survived the last storm series, including a 24-hour power outage that started at 5:30 Christmas morning, and some basement wetting. Took care of that. Currently working on finishing up a Python routine, which allows me to record the dual magnetometer setup I have out in the woods, so I'll be able to get comparison of two magnetometers are only a couple of inches apart. Other than that, just waiting for the end of the year. Back to net.
Fine business. And next on the list, we have Michael, AA8K. Go ahead, Michael.
You. Greetings to everyone on the conference, and back to you, Dave.
Fine business. And next on the list is Tom. Go ahead, Tom.
Good evening, everybody, and Merry Christmas and Happy New Year to everybody on the group. Not much activity here, so back to that.
Okay, so we're no Scotty tonight, so we're open for general discussion. Jules, you came in just a bit late, but I was mentioning that I have an in-ground magnetometer and it's clicking away producing data, but I'm concerned at the magnitude of the X, Y, and Z. They're changing easily less than a unit. And I've been watching Fredericksburg, and over the weekend, supposedly there was some disturbance that showed up in both Fredericksburg and Boulder, but didn't seem to show up here.
Yeah, unfortunately, I was not recording this weekend, working on some other things and occupied by other things as well. What are you looking at nanotesla or in micros? Dave's program prints out in microtesla with nanoteslas in the third decimal position.
Oh, okay. So, well, that's where I'm seeing the variation is in the third decimal.
Yes, you'll be seeing actually, you'll probably, if you look at the Fredericksburg data, typically diurnal variation is plus or minus 20 to plus or minus maximum plus or minus 30 nanotesla. So that's where you want to look.
Okay. And I'm using the settings that you shared with Dave Witten.
Right. Okay.
So they're, I believe, virtually the same.
Yes.
Now, the one I got worried about it, and I changed my A setting from 10 to 1, but I can easily change that back to 10.
Right. And for good resolution to compare it to, let's say, your nearby other intermagnet sites, you really want to do a running average of the last 60 seconds. So take 1 minute data points, but averaged over the last 60 seconds. And I think then you'll find you can get down to 10 nanotesla resolution.
Okay.
Jules, do you think I need to add another decimal points to the log data to give another?
Oh, you mean
digit?
Fractions of a nanotesla?
Yeah, yeah.
I've done that on the y-axis, just because those numbers are small. So if you zero it, if you're fully zeroed, those are fairly small numbers, and I'll throw an extra decimal point in there, but it hasn't made a lot of difference. But it's worthwhile trying to play with. I mean, I have to do a little more playing. It may make a slight improvement in the noise level. But it's something certainly worthwhile playing with. But you can do that. You can do that after the fact, actually, because if you averaged over the previous 60 seconds, that will bring you into the the fractional nanoteslas.
Okay. Well, I'm working on an interface that will quickly, do the computations on the logs and produce a graph and so forth. And I want to get straight exactly what calculations and to what number of significant digits I should be doing things at each point so I don't get it wrong. But I think it would save some people some effort.
Are
Right.
those are those the things you just
Yes,
sent
go
me
ahead.
in the
I'm sorry. Go
email?
ahead.
Are those
Pardon?
the things you just sent me in the email, Dave?
Yeah, that's what I'm talking about. That thing. I didn't send it to anybody but you and Dave, but
Okay.
I can send it to the list if somebody's interested. But
If you want, you can share some of it on the screen now if you want. Talk about it.
oh, okay. Well, it's early days on it. Yeah, let me see. I'm really running a debugger. So, but okay. Let me see if I can share this window. Zoom meeting. Share. Where's sharing this thing? I guess I have to be doing video and share screen. And then
Should pick the application.
yeah, there it is.
Should be
That was
your application.
that should.
That's it.
You see it?
Yes.
Okay. This is it's got a log file reader. I'm trying to make it match the storage scheme that John Gibbons and Bill Engelke have been working out. This just read a day's log file. If you can see that, 75,000 points. It must not have been quite a complete one, but it reads these, loads these things, and I can easily. I'm displaying 3 decimal points. I could easily do 4. It has the ability to do plotting in it, but I haven't. This is not meaningful data. This is just making sure that I had the code mechanism working. But I can feed the data from this directly into plots. Ultimately, find a way to export them so people can put them in publications or something if they want. This configuration should probably be off to the far right, but this is stuff to configure hopefully either a nearby or even a remote setup, at least in testing mode. And then some eye candy things for that if we can think of something meaningful to do, how to present. If we do see phenomena that might be interestingly presented, I can present things that are done with pretty much all the mechanisms that are available to a web, the most sophisticated sorts of websites in here, and I can pull up
one thing that you could potentially put on there is the streamline of the magnetic field vector.
Yeah.
Yeah.
So
David,
if you do the horizontal magnetic field vector at the different stations, that might be interesting.
Yes.
Dave, one thing you might consider, since really we're looking at relatively small variations in nanoteslas, instead of displaying microteslas in 3 decimal points, I would say display nanoteslas, add 1 decimal point.
Okay.
So in other words, instead of 48.000, it's 48,000 for the z-axis. With 1 decimal. I think if you do it that way, it'll make much more meaningful the plots that you then develop from that, because it again, for what we're going to see in general on a diurnal variation, maybe plus or minus 20 nanoteslas max, with a little geomagnetic activity, possibly plus or minus 30, plus or minus 40, but it's not going to go too much above that unless we have a real storm event.
Yeah, I agree with that. And the space physicists are going to be used to reading these units in nanoteslas. So nanoteslas is a good way to do it.
Okay. Make some notes on the back of a paper plate here. Plus 1 SD. Okay. All right. Well, this is a blank slate for the most part here. I
Mhm.
was really just trying to display different bits of functionality that one could kind of just show what could be done. And I'm using, this is all in Python. It, in theory, should run on, it is a local application. It's not a remote. I haven't made a web-based one yet, but it's currently all written in WX Python. So it should run on Windows, Linux. It's running on Linux as you see it, and Mac if you can figure out how to install it. I'm not sure lately that Macs, I think they're getting pretty tyrannical about what you can install. But anyway, it's just a tool. It's just a toolbox as much as anything for me. If somebody else thinks there's something good to put in it, that'll be. But I did want to capture what we are doing in terms of data reduction and creation of a plot into the mechanism of it, just to save a lot of messing around in spreadsheets
Right.
or whatever other tools people choose to use. Won't stop them from using them, but that was my plan with this for now.
That looks pretty cool, dude.
Good. Glad somebody. It doesn't take long to. I've got a couple of bad sheets here and bad logs, but but I loaded a good one.
That's going to be handy, Dave, because working with spreadsheets is time consuming and
Yeah.
gets very boring after a while.
Yeah. Well, if I had known you were still working on a Python script for the dual magnetometer thing, I would have spent some time on that for you. I kind of thought you had that sorted out, but if you need any help with any of those things, please let me know.
Okay,
And,
it was working, but the only problem I had was an accurate schedule. I was using scheduler, which unfortunately slips almost a second every 10 seconds.
oh,
And so I'm now back to APS scheduler under an earlier version of Python, and that's working beautifully.
okay, good. I've gotten good timing in Python in the past with things that were recording a lot faster than this, but I don't remember what I used. So there's a number of options.
And Dave, real quick, which package did you say you wrote this in?
This is in WX Python running, which is the WX widgets encapsulation of the user interface for Python, probably the commonest full-blown interface to use with Python.
Okay.
And it's actually, they're calling it WX Phoenix these days. It's kind of version 4.0 running on Python 3.
So is the window that we're looking at your entire application then?
Yeah,
So
I
you
mean,
have Yeah, so you have a file browser on the left-hand side, and then it automatically interprets the log files.
well, you can select one and it opens it and reads it. I haven't got a lot of error checking and stuff in here yet.
Yeah.
And but it's it's I'm getting things, it's coming together. But the idea is just to have a tool that you can point at a log file and get some results from, and potentially push it to some site or pull it down from our Linode site is the other thing. It would be, you could pull it down or log or not even pull it down, just interpret it as a TCP stream, whatever. And so it's just not to preclude any other efforts by anybody else. Just a gap filler for now.
Yeah,
And,
Dave, do we have any real-time graphing capability?
well, it depends on what you mean by real time, of course.
Well, I mean something that'll be up on the screen as it's running.
Uh,
So we don't have to plot a spreadsheet of data.
yeah, I doubtless can do that with this. Probably, I certainly was going to try.
Mhm.
I'm not sure if I'll have to split some stuff out into threads or anything in here, or else I may just do it with I'm a little more comfortable. I've been using Python for years and years and years, but I've kind of gotten away from doing it because I usually do other
Well,
web
this is
interfaces.
a pet request of mine. Me and Mike
Uh-huh.
Trimpey have always been asking for real-time displays of receivers or whatever instruments we're working with.
If someone wants that, I can at least have it, read, say, a stream from an instrument, and as it appends, these are appended one at a time, and at the same time, I can fire off an event that that plots the data, with the running, running average and whatever other else we're computing that can be computed from a stream, and plot the points and hopefully move it across. If there's someone who wants it, I'll give it a try.
Well, just as we get plots from the world magnetometers, it would be really nice to have a real-time graph running on the screen.
I personally agree with you. I don't really like post processing.
It's great when you're writing a paper, but
Yes.
yeah, post processing, and it's wonderful to get around a lot of limitations and your experimental setup, but it just isn't sexy enough to suit me, I guess. So
and when you see the graph start to wiggle, you start looking outside.
right.
Yeah, I like that.
Right.
Have
And
you, Dave?
have
you been able to use the Linode at all yet?
Well, I interact with it. I get up there. Well, there's two different ones. I've got the one you gave me and the one I made myself. And I've actually been doing a bit of testing on the one I made myself, so as not to leave a lot of detritus behind. Yeah, but when I finally get done, but I haven't really quite made that. I'm basically gonna, it'll be running the, what you call it, the rsync, but I need to be able to, run a script on the Linode side when new things arrive, to make and the idea really is to put a web, create a web page that shows, a hierarchical tree view of the data files that are up there, and be able to click on one of those and just launch it from there and do the same thing that we do. Possibly have a couple of tabs here, one for remote, one for the remote Linode thing. I can make it look just like this, or I can have a web page in there that looks a lot like it. So, but
That'd be really cool.
Yeah,
I guess once you get the data onto the Linode, you could have a real-time view of all of the magnetometers that are submitting data to that one system, right?
Yeah, that's another thing. We could have all these. We could have a view of the nodes with no locations and show if they've submitted any new data in the last 24 hours or something like that. That would be a possibility. Or we can do direct connects, different things. My only reason for showing this to people is so that people have some mental image of the potential, the possibility, and to get a little head start on things like parsing these files so that people don't all have to do it in a rush when suddenly it's, there'll be bits and pieces here that somebody can chop out and use for other things if they so desire. But yeah, this could give some either real-time or near real-time presentation of a few things. Would
Yeah,
be my
once
hope.
we have a bunch of stations, of course, we would want to be able to do real-time stack plots
Mm-hmm.
and be able to, especially being able to see it in longitude as well as latitude.
Yeah, I agree.
So you can watch it travel.
People are just going to have to help me with the maths and and those things. But as far as implementing, some kind of accessible interface to it, I have some experience with that sort of thing. That might
Yeah, this looks
hopefully
very
so.
nice, Dave.
So, get some data under your belts in terms of what you're actually going to see from your magnetometers, and then you can think about how you want to display stuff.
Yeah, that's true. More data we have at the start, the better. One thing is if people will start just logging stuff to the current log location on that the software reads, and I admit I'm behind on getting a final package out there, but even the existing testing software, we can have a script or something to set up the rsync in such a way that it should catch up uploading all those files, when it first fires up, when we first get this thing really going, it catch up and pull all the existing logs. And then as you generate new ones, it'll just push them to the repository as they're created, hopefully. So, well, that's that. I probably should stop sharing that.
Thanks, Steve. That looks really good.
Sure. And I know that Bill's people are all going to do this, the final stuff on all this, but there's plenty of mistakes to be made that they can fix later.
Mm-hmm.
Don't want to take anything away from them.
Oh, just an experiential note that in terms of magnitude of change, depending upon where your magnetometer is located, let's say if it's near a path where somebody walks by or you do any gardening in the area, you run a wheelbarrow by within 10 or 12 feet, and you will see an 80 to 120 nanotesla change in a matter of a couple of seconds. But that's an artifact. That's a human-generated artifact. You're not going to see that in nature.
Rather impulsive.
Yes.
Yeah.
Yeah, basically the human-generated artifacts typically look like impulses, and once in a while you'll see those on some of the plots on Intermagnet also.
Right.
So, have any of you been to the Fredericksburg site? Do you know, is it in remote or is it at a university or a facility?
I don't know. I visited the magnetometer out in Boulder, Colorado, run by NOAA or NIST.
Yeah.
Yeah, I've been to that one, and I spent a week with Terry Bullitt, W0ASP, maybe 2 summers ago, and he gave me a tour of their one of their quiet area receiving facilities, and it called Table Mountain, and you go up there, and it's very on top of I guess the mesa. It's
Mesa,
rather
yeah.
flat, and there's not a lot up there. And he drove me to certain places where he had some radio equipment, and then he pointed to something far in the distance. He said, "Over there is the magnetometer. No one's allowed to go near it."
Yeah.
So that was as close as we could get. We could just
Well,
kind of see it in the distance.
I was curious, so I looked at a map of Fredericksburg, and it's a relatively urban area, not completely, but much more than places I'm used to.
Mhm. Yeah, I don't know.
Nathaniel, when
How-
you said Table Mountain a minute ago, or which Table Mountain, South Africa?
No, in Colorado,
Okay.
near Boulder. It's a site that NOAA and I guess NIST uses.
Okay. There's a Table Mountain on top, up above Cape Town. I thought maybe I missed the first part of what you were saying there. Sorry.
Yeah. Where did they install the one? Dave, either of the Daves. Where did Dolores install the one in Missouri?
It's a place called Bradford Farm. I can show you. Let's see. Can I need a new desktop here.
It's 4.73 miles from my house, but it's probably a mile to a mile and a half from the US Highway 63, and probably there are airplanes that do fly over that area, but not many.
So that's extremely close to you.
Yes.
Yeah.
So that means that anything that one sees, pretty much your magnetometer should see the same thing.
Can I share?
Yeah, you should be able to.
Okay. And here is, so I live over in this area.
Mm-hmm.
Dave lives right up here, this area. And the magnetometer is, you see where this is a university farm. It doesn't look like other farms. The weather site is here. The buildings are here. I assume they put the magnetometer at somewhere near the weather site, which is here.
Mm-hmm.
Can you zoom out from that? And then
You mean in or
out? So people can see where it is.
So this is where the research grade magnetometer. Dave lives here. I live over here.
Mm-hmm.
So we have those three.
And it's pretty quiet rural around there, though they do have some combines and things.
Have we emailed Jennifer Gannon?
I think it would be good for you to email her, Nathaniel,
Okay.
because both of you have NSF grants.
Yes.
So
I'll be happy to do that.
one is a 2 and one is a 3, but
Yeah.
just ask for cooperation with sharing magnetometer data. They've implied that it was available at least for this one site.
Mm-hmm.
But I have not contacted Jennifer directly. I've only worked through Dolores.
Yeah, since Jennifer's the PI, I'll send her an email
Now,
and ask
Dolores
if,
is a co-PI,
okay.
and I think
I can
they're the
email
only
both of them.
two.
That sounds really good. Yeah, I'll email them, and since their magnetometer is so close to ours, that would be a really good validation.
Yeah. So it will be, if you see, basically all these are research fields
Mm-hmm.
in here. And so that's the research farm.
That's good.
And Dave was mentioning our airports down here. And the main runway goes kind of just a little east of there.
They should be pretty well off the ground by then.
We
I would
had some
hope.
trouble with flying drones at this site because it's in controlled airspace.
Mm-hmm.
Now there is another research farm here. And there is a 800-foot TV tower right there where the cursor is. So just a little, look around our part of the world.
Yeah.
This is where the university is here.
A basic college town out in the middle of a cornfield.
And we're not far from the Missouri River. Okay, I'll stop sharing.
Nice.
And Nathaniel, the name for that site is Bradford Farm.
Okay. Thanks. Yeah, I'll email Dolores and Jennifer tonight then.
Yeah, and just refer to you communicated with me.
Okay. Thank you. Yeah, I think that will be really good. I have my magnetometer board here, but I have not yet gotten it set up yet. I was gonna try to get the grape going first, and then once I guess Dave makes a little bit more progress with his software, then I would try to get the magnetometer set up as well.
I'll try to knock some of that out here. I've just not had a lot of crosstalk and needed to work on something else as well. Get a little cross-eyed.
Daniel?
Yes, Jules?
Yeah, I sent earlier an email off to Hillman and you, and I think, and Dave, that I did have my original embedded magnetometer, which uses one of Dave's boards, but which is perfectly compatible with the local board that Scotty has now. And rather than wait for the boards to come through from Scotty, I could send him that over the next day or so if he needs it.
Okay, over to Hyomin.
Yeah.
Okay. Yeah, I guess we'll see what Hyomin says.
Okay. If he wants to wait, that's fine too. But if he would like something a little sooner, I can ship that off to him because that's working.
Thank you. Yeah, I just sent. Has anyone heard from Scotty this past week?
I haven't seen any traffic. Nothing on the Tapper site.
Yeah.
I texted with him maybe 5 or 6 times this week.
Okay.
He was feeling better, but he's still not feeling great.
Mm-hmm.
And Nona is also ill.
Mm-hmm.
So I imagine that they're kind of dealing with that these days.
Yeah, I know. I guess I had last spoken to him about a little over a week ago. So I know they weren't feeling well then. So I was hoping they'd be feeling better soon.
Does he have COVID?
Yes.
Oh, that's all. Hope he's okay.
Yep.
Yeah. So yeah, I hope they get better soon.
I did see an announcement that HamCon which is supposed to be in January, I believe, is being canceled this year.
Is that the one that's in Florida?
I think this is I don't know exactly where it was. I have to look back at my emails, but Did you see those emails, Dan?
I did not, but Hamcation is the name of the event in Florida.
Yeah,
Yeah,
that one we haven't heard anything about. I do know that Dayton is trying to get vendors to sign up.
Is Tapper having a booth at Dayton this year?
Well, we're debating it.
Yeah. I'm
Half the
debating
people
it.
want to and half the people don't want to.
I'm
Well,
debating it too.
whether
for Hamsci.
whether they want to go.
Yeah.
And the issue is it could either be just fine or it could be a big problem, just depending on how fast everything moves.
I'm leaning toward, not doing a Hamsci booth this year and then going back again next year.
Yeah.
Because it's just it's too much in the middle of the vaccine rollout. Things aren't back to where they should be yet. And I really doubt that even by May. I think it'll be better, but I don't think it's going to be 100%. And if I'm trying to bring students in, then you have university liability.
Getting presenters is a real nightmare at this point.
Yeah, and it's going to be right during my final exam week, and yeah, getting presenters and people, it's going to be a lot.
Yeah. And for Tepper, our thing is we're not like a commercial vendor that's trying to sell radios and boxes.
Yeah.
We're just trying to get people interested in projects.
And same thing with me. I'm not.
And so that's a very different thing. And actually it's easier to do that online than it is. We talk over and over to individuals, but we're probably more effective by presenting a video conference.
Mm-hmm.
That's true. I mean, being at Hamvention or Dayton or something like that is like waving the flag, showing the flag. You're there, and you can say to the NSF, yes, we presented this in a public forum, but you're probably going to reach a lot more people through a virtual video conferences.
Yeah.
Now, I also have to be sure that I point out that there are differences of opinion among the Tapper board members. So, and in a normal setting, there would be no question. We would attend.
Yeah, same for me.
But the real question is, how far along the recovery will we be by May?
Right. And that's where I'm coming from too. I agree with that.
Yeah.
And I just don't see it as really being a beneficial activity this year. It seems like more of a boondoggle.
Some of the stronger proponents are people that live in Dayton.
Yeah. Well, that makes sense. I mean, so certainly for people who go there, but who live there, that makes a lot of sense. But for people who have to travel far distances,
yes,
and do a lot of organization. Yeah.
Yeah, I've probably made Dayton 15 years in a row up until this past one.
Yeah.
Mm-hmm.
And it's a hike to get there. I mean, for me, it's about a 10-hour drive.
Yep.
Mm-hmm.
So.
Yeah.
I know people who've been there every year for 35 or 40 years, I think.
Yeah, I do too.
Go this year.
Yeah.
I think next year, at least I'm certainly hoping next year, with the I'm hoping that the vaccine will be rolled out. Things will be a little bit more normal.
Are you referring next year being 22?
22.
Yeah, 2022.
Yeah, I think.
And then hopefully we'll actually have Tangerine SDR hardware to show.
Yes, that would be nice.
That's
great.
Somebody there who built it to show it.
So I can tell you, as soon as we have these prototypes available, if we can get an emulation mode for this thing that essentially emulates and edits GMT201229 at USRP. I'd really like to get that rolling because I want to do more of this ionosonde receiving, and we want to build out a little network of these things centered around the ionosonde located in Virginia, in Chesapeake Bay, Virginia. And so we had Dev Joshi, Phil Erickson, Ethan Miller, myself, Yuha. We all had a telecon about a week ago talking about this, how we want to build out, get 4 or 5 or more receiving stations in a 500-kilometer radius around the ionosonde. And then we have some plans on how you can take that data and pull out the TIDs and hopefully look at which way these things are propagating in that data. So right now, in order for me to make these measurements, it basically takes a $3,000 USRP and another $1,200, $1,000 to $3,000 computer to do the receiving with the way we have the software set up right now. So as soon as we can get tangerines that are prototyped and a little less expensive, and also not only just less expensive, I have some money, but I want to be spending the grant money on buying tangerines and not USRPs, because we're supposed to be developing the new thing. So as soon as we can do that, I really want to get these deployed at some stations, like even Frank Donovan, W3LPL. He's very interested in running one of these things, but I don't want to just send him a USRP. I'd rather send him a tangerine.
Yep.
So
Yeah, that'd be great, Nathaniel. That's really encouraging because we've got an installed base of USRPs as well.
yeah,
Designing the Tangerine to be software compatible would be great.
Yeah. So if we can, as soon as we can do that, I will be very excited. And Dev, who just joined our chat here, he will be very excited also.
So one comment about the USRP software for ionosonde and the sounders is it's sort of integrated into the control software for the USRP. It's not really a standalone program that runs by itself. I mean, in order to use Yuha's software as it is, you'd have to be able to emulate USRP 100%.
What you need to do to get Yuha's software to work is really be able to have a radio that will stream 25 megahertz of IQ data. So and have it be GPS time stamped. So if you have a radio that's capable of doing that and a system that's capable of doing that, and if you're able to if you can hand Yuha an IQ data stream that meets those requirements,
So
you should be able to do what you need to do with this.
what is the resolution of the 25 megahertz? Is it every hertz or every?
You just need to be able to sample 25 mega samples per second.
Okay.
IQ.
The time stream, not frequency.
That's what I was wondering about, is the time. Okay.
Just a side question on that. I know the EDIS USRPs are using FPGAs with built-in processing power, and they're actually utilizing some of that in the signal chain. Is that something you'd have to duplicate, or?
No, we're doing that.
You're doing that?
Tangerine does that.
The whole RF knock stuff that they do?
Well, it can. It has the FPGA engine to do it.
Yeah, right now I don't know of plans to emulate RF knock in the FPGA. That's a really big, complicated library. There's a white paper on the Tangerine site about things we can do for ionosonde processing in the FPGA. That would be different from and not compatible with Yuha software. So I think, as Nathaniel says, we need to look at some simple things we might be able to do in the FPGA to feed the code. But I don't see implementing the whole RF knock library. It's a pretty big library.
Well, I knew it was pretty big. I just didn't know if there were pieces of it that would be required for this specific instance.
Yeah, I don't think we've currently looked at building a RF knock like tool chain for Tangerine. I mean, that would be deluxe, but it might be a larger project than this team is capable of handling.
Yeah.
So probably we'll look at a few dedicated loads for a couple of different modes of operation. I think
Well,
that's a little more practical.
Well, Tangerine's open source, so if somebody wants to do it,
I'm not
it'll be done.
so I'm not familiar with RF knock exactly. So what exactly is it?
What RFNet does is it allows you to instantiate in GNU radio the signal processing blocks inside the FPGA. And so you can wire them up as though they were software radio processing blocks on the computer, but they're actually executing in the FPGA. And so the tool chain has to look at your block in GNU radio, and it has to figure out how to compile that and ship it to the FPGA, wire it up, and have the FPGA compute it.
Wow. Okay.
That's a pretty tall order.
I see that from a quick Google search. It says here that RF knock is integrated with the UHD software in all USRP devices from the 3rd generation on, which includes the X300 series and E300 series are supported by RF knock out of the box. So does that mean the N200 and N210 are not RF knock compatible?
That is correct. They use a different FPGA that's not compatible with the RF knock toolkit.
Okay. So from naively based on that, then UHA's software would not require RF knock because we're just using N200s.
Okay. Yeah, so I think we might simplify things, at least initially, by focusing on a couple of modes of operation for science campaigns,
right?
And hand coding those in the FPGA, and then seeing where that takes us.
That sounds good.
I think we'll get from A to Z a lot faster with that kind of an approach.
Yeah.
Yeah, we may end up having something similar, but of course it's a different, they're using a different FPGA, so they're using Xilinx.
UHA's approach has been just get me all of the IQ data onto off the USRP and onto the GPU or onto the CPU on the main computer, and let me just do all my processing in like Python. So
yeah, so so one of the modes could be to capture wideband data, and when you capture wideband data, you don't use I and Q. There's only a single real component. Then you can figure out perhaps how to pack that as 14-bit binaries or something, and there may be a way to slow down the data rate. So that may be one mode that's useful, and the white paper talks about other modes, narrowband dechirpers and things. So I think we have a couple of interesting experiments we can run there to decide how we want to put all this together.
Yeah, that's good.
And since Scotty's writing all the FPGA code, we can put all that on his table.
Yes.
Oh, he'll love that.
Yeah.
It's up to Scotty. Well, I thought the idea was to put individual receivers in the FPGA.
Well, yeah, that's certainly, I think, something that if we can get to the point where that works and we come up with a derivative of UHA's code to do that, makes processing, computing, and data transport a lot simpler problem.
Yeah.
Because what we're doing for receivers, we're looking at multiple channels, many channels at once, and then downsampling each of them to very low bandwidth. But we're currently running 6-channel, but actually more than that. Doing it on the Raspberry Pi, but it would be really good. I mean, that's what the FPGA does very well. It's doing all that processing.
Yeah, once you know what you want to de-chirp and you know the parameters, starting time and starting frequency and chirp rate, things like that, the de-chirping process produces an output very much like a 48 kilohertz receiver slice. It's really not any different than that, except it's at a 45-degree angle, so to speak, because it's been de-chirped. And so that's a fairly economical implementation in an FPGA.
I will mention that FPGA programmers are a rare commodity.
That's what I've heard.
Yes. So if you know anybody who is one, try to get them involved.
Well, I'm a little rusty, but hoping to get up to speed again.
Is this
I will tell you,
is
Scotty can't.
FPGA programming, is this the sort of thing that a master's student in software engineering would be interested in learning how to do? Or is this
Not too many of them.
They should
Yeah.
be.
It's more
should
electrical. It's more
Yeah, but-
electrical engineering.
Yeah.
Right. Well, so here's the situation at the University of Scranton for people who don't know. We do not have PhD students. So I do not have a master's. We don't have any master's students in electrical engineering or physics either. But what we do have are master's students in software engineering. And so in my grants, I'm able to write for graduate assistants who are Masters of Science students in software engineering. So I know at least one student who I'm hoping to have on a project starting this summer. He actually he's graduating with a bachelor's in computer engineering right now and will be starting in the Masters of Software Engineering program in the fall. So I don't know if this is the sort of thing that for the future I would want to get a MSSE student involved in.
Nathaniel, here at Dartmouth, we are teaching FPGA programming in the engineering school to
Yes.
undergraduates.
Are you?
Not programs quite as complicated as what we've been
No,
talking
but getting them started with it.
Yes.
And
Yeah.
doing actual SDR programming. That's what it's Eric Hansen, who I know well. We're both, he and I basically make up the Dartmouth Amateur Radio Club right now.
Nice.
But,
It's
he is teaching the undergraduates FPGA programming and using SDR as the platform, what you're developing.
it really depends on the students that you happen to have, I think, in the situation you're talking about. Yes, they should be interested in it.
As I'm thinking
it's
about it,
not on the list of hot languages.
as I'm thinking about it, we may want to see if Eric wants to get in on the project.
You might.
That'd be cool.
This would make a project using this hardware might be a very interesting student group project.
Yes. It would be interesting to figure out better ways to get more students involved in these projects.
Right.
I think, well, since it is springtime, there may be students in ECE 340 that would might be interested in taking on some of the FPGA work. ECE 340 is where Dr. Berger teaches Verilog.
So Dr. Berger does teach Verilog.
Yeah. Actually, he has a teaching assistant, like one of his better students. They kind of teach it for him. Ellie taught it this past spring.
Oh, really?
Yeah. And it was I think it was 6 projects total, 6 basic projects, starting from the beginning all the way to making a countdown timer. And I plan on doing the Verilog for the VLF stuff as well. I'm I'm very new to it, but I do want to learn more. So maybe if you talk to Dr. Berger about 340, you may be able to get some takers as well.
That would be neat.
Yep.
You tell them that it's their one opportunity to learn a computer language that's distinctly different, truly different
It is
than
not
any of the
sequential.
others. It is, it's anything from Lisp to JavaScript are all really the same language.
How about
just
Piet?
arranged different.
How about Piet?
Piet,
Yeah.
there's always something. I don't know. I'm not. That's out of my. But there aren't many that are really, truly, fundamentally different under the hood. But Verilog or VHDL are truly different, and Verilog's the way to go.
So I think the main issue with Verilog programming, and more specifically FPGA programming, is that writing the code is only half the job. The other half is troubleshooting what you've written and making it run correctly.
Yes.
You look at most FPGA projects, they're like 50% getting something working and 50% making it work correctly.
Yeah.
Now, why do you say Verilog is the way to go?
Well, pure bias, pure.
Yeah, bias from my previous engineering team who griped loud and hard about VHDL.
Pure unmitigated point of view.
What?
I'd like to bounce another question out there. I was just looking at the web page for the Analog Devices Pluto. It's got an embedded Xilinx FPGA. Does anybody know if that's user programmable? I know it comes pre-programmed.
I think it is.
Yes, it is.
And
so you could change the code in the
and just
in the
as
FPGA.
well as the red Battaya, you can
change that too.
Yeah. Mm-hmm. And you could program any of the open HPSDR radios if you want, if you know what you're doing. There's nothing stopping you except your knowledge.
Yeah.
I put the link to the Dartmouth engineering course in if anyone wants to look at it. So we do have
there it is.
A base of students being taught.
Now, I need to go. I'm going to say 73.
All right, Dave. Thank you so much.
Yep. Very good.
7-3's Dave.
7-3's Dave.
7-3. Dave McGaw.
Yes.
Jonathan Rizzo over here is in the market, as it were, for graduate school. So if you want to do any recruiting.
Well, you certainly should check us out. You do, the ground research we're working on here. We do rockets. We do balloons. We're getting very much into CubeSats. We got 2 CubeSats running right now, as well as other sides to physics.
Do you have any VLF projects up there?
Not per se, but we should. That's actually what started our group was Millette Morgan was a VLF guy. Essentially competing against Stanford. Then he went to building ionosons to study gravity waves. But he started our space physics group way back when.
Yeah, I think Jonathan's interested in some place he could go to work on VLF stuff.
Well, there's nothing that says we couldn't do that there. I mean, certainly fits in with our space physics group. And, we got a lot of experimentalists and theorists, and they work back and forth to try to model what's going on.
Do you think that developing my VLF hardware would be something that would be useful?
Well, yeah, probably. I mean, Dartmouth loves people to bring in grants.
Okay.
I think Jonathan, I think you should pick a place you want to go, and I think you should write one of those GFRP, graduate research fellowship program applications. They'll be due in the fall. It's only 5 pages you have to write, but they need to be 5 inspired pages. But I think if you work with an advisor, I think you could write the correct inspiration down.
Yeah, another thing that we've gotten into, but not haven't gone too far, is lightning research. We've been doing it from the X-ray side, but VLF is very much there. And in fact, I'm trying to remember if Jim LaBelle actually says he started out on VLF. I think he did. Anyway, you should check us out at Dartmouth.
Okay, well, writing up 5 pages isn't bad, because I wanted to develop my hardware and basically get it to a point where it could be something that people could use and set up their own receivers. Kind of similar to what Nathaniel is doing with the Personal Space Weather Station.
Right.
Kind of
well, I'll just also point out that Jim LaBelle, who I worked for, he's going to be retiring in 2 to 3 years, and there will be a hole in the department. Nothing says he can't come in early, but now keep an eye on it.
Okay. All right. Will that be like a bad thing once he leaves? Will I need to find another source of money, or?
Well, they'll be looking to fill the position.
Oh, okay. All right. I'll.
We're constantly turning over. We've got a lot of new faculty. So, yeah,
okay. All right.
It's worth a try. It's stuff we do or stuff we're interested in.
All right, good.
And you can also, by the way, it also crosses with the engineering department. There's Simon Shepard, you might know, he's super darn. He's over actually in the engineering department. We have
spent a number of happy weeks with Simon on Adak Island.
Right.
Oh. Okay. All right.
And the engineering department, by the way, is expanding tremendously right now. They're going to be like 2 times as much space as they had.
Wow.
And they'd already gone through an expansion.
Okay.
So look there too, as well as the physics department. Our space physics group is split between them.
Okay. All right. Sounds good.
Well, I might say 7.3. I might continue working on my cable management a little bit. And then I will.
So much for wireless.
Oh my gosh. I have like, my desk here is maybe 4 foot wide and 3 foot deep, 2.5 foot deep. And I have so many things on it. But I'm sure that's actually probably not a whole lot compared to what some of you guys have. So. But yeah, hopefully when I'm done, I'll have the Grape connected, I'll have a Kiwi SDR connected, I'll have a Chirp Iono sound receiver connected. I'm gonna maybe even two of them. I'll have an antenna switch where I can switch between transmitting with the IC 7410 and listening with all these other devices. And so I'll have everything all networked and connected and all that other stuff. So, and I finally learned how to use auto SSH so I could connect out to one of my Linodes and have it forward my ports back in so I can put my computers wherever and always be able to get back to them. So
Well, that's interesting. I don't know about that.
oh, it's fantastic. So the way it works is that the problem is if you are behind any sort of a firewall or if you don't have a public IP address, how do you SSH into your system? Well, what you can do is you set up a server somewhere, in this case a Linode for $5 a month, and you run auto SSH on the machine you want to be able to SSH into. And what it does, auto SSH keeps an SSH reverse tunnel connected to your server. So now I just SSH onto a port that I designate on my server, and then it automatically tunnels it through my client machine. So now I could put this machine on any network I want, as long as it has the internet and it can SSH out to my Linode, I can now SSH back into it.
Mm-hmm. Mm-hmm. I've been fighting with DNS and such and trying to get some names assigned and stuff into those Linode instances too, or at least mine. So,
yeah.
Yeah, I'm not sure what we're doing, but we're doing similar with our AM Dopplers. They're
Ethan Miller,
externally accessible from anywhere.
Ethan Miller told me about this trick.
Mm-hmm.
It was good. What happened with your DNS with the Linodes, Dave?
Oh, I haven't really gotten too far, except that I just got frustrated with the jargon and communicating with whoever it was. I have had some registered names and things for a long time that I haven't used, but there's so many. In order to, just all the things I have to do to prove I own them, because they've mostly been parked, and I was going to set up a dynamic DNS to some of my own stuff and some and probably for my own Linode instance, I was just going to give it a name, but I may have just got confused and frustrated, but I got real aggravated with Rapid SSL and some of those deals. So, and I don't know. I need to get back at it. I guess that's a project for this week too. Stuff. Have you done that?
I'm running a dynamic DNS. I use deerfield.com. And so I have like hamsci.org, hamsci.com, w2nf.com, and w2nf.dg.com. They all go through this Deerfield system. And then it's dynamic DNS. So I just tell it to point to whatever IP address I want it to, and it changes it instantly, basically. So
sure.
I've been very happy with it. It's kind of one-stop shopping. So
I'll try to do that.
Yeah,
I'll give them a look.
It's called DNS to go or D2G.
Okay.
Yeah. And they do my domain registration and my and the DNS dynamic DNS, so it's all through one company, so I don't have to think about it too much.
I've had a cluster of names parked at GoDaddy for some years, I think, and
yeah, that's what I'm using.
Let's see.
Yeah, same here, Dave, and haven't done anything with them either.
Yeah. Well, I'll give it. I'll chase that this week.
It probably costs a little bit more than I want to spend on it, but I set it up years ago and it works. So I don't
Inertia's
touch it.
inertia's one of the most important forces in the universe.
Yep.
All right. Well, I better go to.
Yeah, I think I'm going to say 73 as well, group. Have a good, happy new year. See you next week.
Happy New Year, everybody.
New Year.
Bye.
New Year.
Bye bye.
Sure.
73.
73.
73.